Alright, so let's talk about continuous compound interest. So continuous compound interest, it takes on the form A equals P times E to the power of RT, or you could call it the pert function. Some of my students in the past have. Okay, so A, this is the amount after T years. Okay, and P is what we call the principal, meaning the amount like you started off with. Alright, so this is your principal amount. Then you have R, and R is your annual interest rate. Annual interest rate. And we have T, and T is the amount of years. Okay? Look at an example now with continuous compound interest. Suppose you deposit $700 into an account paying 3% annual interest, compounded continuously. What is the balance after 8 years? All right, so this is continuous compound, which means I would have to use the pert function. All right, y equals PE to the power of RT. Okay, or actually instead of y, we called it A. Okay, because it's the amount I get after those amount of years. So let's see, what is our principal here? What do we start off with? We start off with $700. Our rate is 3%, change it into a decimal, you get 0.03. The time after years is 8 years. And I will plug this all into my function. All right, so A, the amount after 8 years, principal is 700, plug it all in, e to the power of 0.03 times 8. And you can choose to plug this all into your calculator, and we get about $889.87. Okay, so this would be our amount using continuous compound interest after 8 years. Okay, so let's continue. All right, what if the example, let's say this example has a part 2 to it. It says, how long will it take for the balance in your account to reach at least $1,200? So I want my amount to be at least $1,200. So I want it to be A, my amount should be at least that much. So I want it to be 1,200. My amount should be greater than 1,200. So I want my pert function to be bigger. Okay, so I want 1,200 is less than or equal to, all right, we have our principal, which was 700. So let's plug in what we have, e to the power of 0.03. And then we don't need 8 years because we want to see how long it will take this time. So t is in question. Okay, so now let's go ahead and solve this. So let's go ahead and divide 700 on both sides. All right, so I have 1,200 over 700. This is less than e to the power 0.03t. Okay, and then the next thing I have is I will have to take the natural log of both sides. So this equals, I'll write it up here. Take the natural log of both sides. I'll simplify at the very end. And then this is less than natural log of e to the power of 0.03t. Bring the power out by the power rule. So you have the natural log of 1,200 over 700. And this is less than, what, 0.03t ln of e. We can actually simplify what's inside of it because our zeros will go away. So we have ln of basically 12 over 7. And then this is less than ln of e, natural log of e is 1, so it's 0.03t. And then finally, I will divide by 0.03 on both sides. Divide by 0.03 on both sides, and then I will finally have t by itself, and I'll have a constant on the left-hand side. So my constant on the left-hand side, I have natural log of 12 divided by 7, and then I will divide that whole thing by 0.03, and I will get about 18, right? It's about 18. So the time in years it will take for it to reach at least T will probably be at least about 18 years. All right, so we can say about 18 years. Or T greater than 18.